Here's the wash rack area that I'm going to install this little giant sprayer boom. This little giant sprayer boom here, got off Amazon. It is, I think, 6 to 8 foot reach, with an adjustable boom. It has a little set screw there that allows you to adjust how much the boom comes out. You will see there that the packaging did have some marks on it from just the cardboard all along each one of the components. This is your extension boom that will have the hose hang out of it. This is the boom that basically attaches to the wall where the rotation happens here. This is the connector bracket that basically bolts to the wall and then goes up into there for it to rotate on. It does come with some hardware here with the sprayer there, and then these for the hose. I don't plan on using these, and we'll talk about those in just a minute. Does have some hose that came with it. These I bought separate, those don't come with it. Don't look at those. Here, these are basically the lag bolts that it came with. I'm not going to be able to use those either, but I'll show you my setup. So starting with this hose that it comes with, 5/8 inner diameter. I bought these online. Here you go. It has a nipple there that you slide into the hose, and then you put this collet over the hose first, and then when you screw it down in there, it basically tightens up on it. We'll let you know how those work. Haven't tried them yet, obviously, but they're a lot more robust. They're actually aluminum. They're brass coated aluminum. Because the issue is with these that came with it, there's two different ones. Let's zoom in a little. So you can see they're a little bit different. They're designed so that they have like a shark bite fitting on the end here. But this is designed to just push directly onto the hose and then bite onto it down in there. Now the problem with that one is it's plastic. It is a quick release system, which is a really good thought, but it's just not executed well being plastic. So that one is completely pass through. That one would be the one that connects to your water source. This would go basically on the spigot, and then that would connect to the other hose, the black hose here. Now this end is basically the one that would typically go onto the nozzle here. This would screw into the nozzle. And then this would be the connection that goes to the hose. This end would go to the hose. Problem with this end is that, again, it's this shark bite deal, and it's a clever design in the fact that it's supposed to be an auto shut-off when the nozzle's not attached. The problem with that is that when it is attached, it pushes this little plunger back. This little plunger, it's basically the same inner diameter almost as the hose. So there's a massive flow restriction by using this. And you can see the flow goes down those little fluted areas there. And so there is just a huge amount of flow restriction by using this particular plastic component. So because of the flow restrictions and because they're plastic, I've chosen not to use those. This is what I went with. This is simply from Tractor Supply. I'm rather impressed with it. It's affordable, and this one is the side that basically would screw on to your hose fitting, and then this side would be what screws into your, let's say here, your nozzle. That's what's screwed in there right now is one of these quick connects. They're solid machine brass. There's no burrs. The best thing is that when they're connected together, I can't do it one-handed, there's basically no flow restriction. It's a really nice open flow pass through there. So these are what I'm gonna go with on the ends connected to the nozzle. This is sort of my mixing setup right now. I do have hot and cold, which is nice. But one of the things that you have an issue with is, you know, on long hoses, it's difficult to get, if you're trying to use a valve like this, the right temperature, unless you already kind of know where to set it. So I'm going to go ahead and install a thermostatic mixing valve that will allow you to set the temperature, and then it will just maintain that. Here's my thermostatic mixing valve setup. So this is the valve. You can see here that it basically has individual temperatures in Fahrenheit around the collar here. Then there's a push button if you want to turn, here's a little set point, if you want to turn this past 100 degrees up to, what's this, 122 degrees, you do have to press in this little button first. But it basically allows you to set that, and then this is the hot side, this is the cold side, and this is your outlet. So whatever, basically it automatically mixes, and then that temperature comes out here, which is really nice. So what I've got here is, these are a 3/4 inch National Pipe Thread, NPT. There's a lot of reviews on this that says they're not, but when you really look at the pictures, it looks like different models of the valve have been in the images. These are NPT, 100%, all three of these. So then this is an adapter from NPT to GHT, garden hose thread, and then these 90-degree fittings. These allow really good flow. I picked this 3/4 inch size. You can get this, I think, in 1/2 inch too, the outlets, but I wanted the most flow I could through here with little restriction. Now these valves, mounting them is sort of problematic. I don't really know exactly why there's no tabs or eyelets or standoffs or anything on the thing to mount it. It took me quite a while to locate one of these. This is basically a through-hole bulkhead fitting for a tank or something like that. But what was so difficult to be 100% sure is that this has 3/4 NPT on this side, threaded in, and 3/4 NPT on this side, threaded in. It's not like garden hose straight thread or anything through it. They're two separate threads on each side, so you can thread into both sides. It is stainless steel, so you have to be careful about galling. It came with 2 of them. This one I threaded down on by hand and it got stuck. So I do have some anti-seize that I'm gonna put on the final one. But it has kind of a plastic washer here. Can't get it to come off of there. It's got a funny shape to it because there's sort of a lip down in there. So this would be really good fitting into a tank or an IBC tote or something like that. These are really nice. They weren't that expensive either. But the deal, what the idea here is that I made a bracket that will allow this bulkhead fitting to tighten down on it. Bolt it to the wall, and it will hold the whole kit and caboodle here up. And then from there, I've picked up a really nice ball valve. Again, this is 3/4 inch, and it is a full flow. So when you look through it, it's not a small ball valve in there, it's a full flow. And then screwed into that is 3/4 NPT here down to garden hose thread. And then thread one of these couplers right onto the bottom of this to hook the hose to the boom, or any other accessories that I want to come right off of this. One of the other things I'm not terribly pleased with is when you put this mounting bracket in, there is a lot of extra play in it. And I really don't want that much slop in this. So what I've done is I've taken a thin piece of cutting board and I've cut it to be this 8 1/4 by 6 1/4, and it's gonna basically wrap the tube and sit inside of that and act as kind of a bushing so that it'll take up a little bit of that space and prevent the metal on metal wear inside. Oh, that's the theory. So I'm gonna mount this right there on that sort of stanchion area, and it'll swing over this way when it's out of service. So I ran into an issue. I can't reach high enough, but in my mind, I thought that this bracket would span just nicely those two metal sort of square box tubing. In the end, it turns out it's too wide. It does not span the two of them. At the top, you may be able to see the width of this. That way, the width of that bracket will go there, but this one will have a bit of an adapter plate almost. The plate will screw in through the main bracket of this into that one, and then there'll be a sort of an ancillary screw that screws through basically this plate that goes across, and then over here where I'm pointing will be a drilled hole with another one of these rivnuts in it that will allow proper bite from the screws. So the issue with my metal here is I also didn't want to use a self-tapping screw because it just isn't sufficient for what the needs here is. So I've put in 5/16, I think -18 rivnuts to take screws. You can see here that, we'll call it bushing, installed now. And it has a really nice feel to it when the arm is in there spinning over the bracket or post. Here's the first test fit of the bracket. You can see that one hole that's sort of floating. Looks and feels really solid. Here's the test fit of the boom arm without the extension in it. Let's see if we can climb the ladder. Almost. But it's a really smooth action here with that bushing material in there. No real play or anything. Any movement you're seeing is actually the bracket moving, since I just hand tightened it for now. Got the hose installed. Used this dry lube here. It actually worked really well. I just kind of sprayed the hose on both sides. I made it into like a little cinnamon roll and sprayed both sides and was able to get it into the boom. 2 people would probably make it easier. I also used a string taped to this end to kind of pull it through when it got in that corner. I stuffed it through that piece first and then pulled a bunch through and then stuffed a bunch through that till it was hanging out, and then I brought it up and put it up there. So 2 people would make it easier, but it's doing good. Next step will be getting the fittings on the ends. They seem to be pretty nice so far. I spray lubed this again and the little nub here, and then you just kind of tighten that down. And I'm gonna put a little bit of anti-seize on this too, since it's aluminum. I don't want it to gall or anything. So pretty good so far. This is the bracket that will basically span this gap here. It's like an 1/8 inch, which is pretty heavy duty. It'll do pretty well. Go right there if you can see kind of the deal. Let's see if we can get it to fit. Plate fits pretty well. I'm pleased with it. What it does is it takes a clamping force here and clamping force up under here, and it means that this plate is bolted to the frame, and then the little tab that's sticking out here has that rivet nut in it. And it allows it to distribute the force nicely amongst that. Real quick recap. Make sure to use a little file around that cut end. It's a little sharp in there, and the weld seam is a little bit sharp. Same thing up here. It's not my finger. The weld seam in here is sharp, so is where they punch through for that set screw. File the round end of that too. Same thing here, file the round part of that. This one I forgot to file and had to file with the hose in it. It was real sharp there as well. That'll get most of the sharp stuff off. A bushing up in there. Find some nice ends for these. I'll see if I can get everything in the description that I ordered. Adjusting the mixing valve, super easy too. Right now, about 95 degrees. You want to go above 100 degrees, you press the little red button. There you go. Well, let's test it out, see how it works. Take a look here. Did a little bit of a temporary hose for filling buckets and whatnot, using some of the included hardware with the boom. I'll probably change that out. I'd also like to upgrade these to stainless steel braided at some point, but water's on. There you go. Good flow there. If we want to use the hose boom itself, pop that out. Snap that in. I do need to also find a nice way to hang this up here. But let's get our boom out. See how it does. Layer on the line, but you can see it's got pretty good pressure. Saw some of the reviews online said it wasn't a lot of pressure. If you end up using the included hardware, I can understand that. So, quite happy with it.